Okay, I'm going to finish up section 3.5 here. So we're on page 251, problem 26. Get that right here. So the question is, suppose that we have a function, f of x equals the square root of x. Write a formula for the function in part A that is reflected about the x-axis and then shifted to the left 2 units. Okay, so if we reflect about x, I need to have the square root of x needs to become a negative square root of x, and if I shift up 2 units, or to the left 2 units, the left 2 units means that I got to go x plus 2, and so g of x is negative the square root of x plus 2. Part B, suppose that we reflect about the y-axis and then shift to the right 3 units. Okay, so if we reflect about the y-axis, we got the square root of negative x, and then I want to shift to the right 3 units. To the right, I need to replace x with an x minus 3. G of x is the square root of negative the quantity x minus 3. Okay. Problem 36, part C. Suppose that we want to graph y is equal to 2 times f of x, f of negative x. Okay. So f of negative x means that I want to take the original graph and reflect about the x-axis, all these points. So 3, 1 is going to be at negative 3, 1. Negative 1, 2 is going to be at 1, 2. And negative 2, 1 is going to be at 2, negative 1. Okay, and then I want to vertically stretch the graph by a factor of 2. So negative 3, 1 is going to be at negative 3, 2. 1, 2 is going to be at 1, 4. And 2, 1 is going to be at negative 2, or at 2, negative 2. And that'd be y equals 2 times f of negative x. Problem 98. Okay, problem 98. The points negative 12, 6, 0, 8, and 8, negative 4 are on the graph of y equals f of x. Determine 3 points that lie on the graph of y equal g of x. So g of x is f of x plus 1 minus 1. Okay. So f of x plus 1 means I go to the left 1, and the minus 1 means I go down 1. So negative 12, 6, when I go to the left 1, that'll put me at negative 13, 6. Then go down 1, it puts me at negative 13, 5. 0, 8, when I go to the left 1, that'll put me at negative 1, 8. And then when I go down 1, and that'll put me at negative 1, 7. 8, negative 4, when I go to the left 1, that'll put me at negative 7. That'll put me at 7, negative 4. Then we go down 1, that'll put me at 7, negative 5. Okay. Problem 100. G of x equals negative 2 times f of x. In the same 3 points there on the graph of f of x. Let's see here. G of x is equal to negative 2 times f of x. G of x is, basically I'm going to multiply the y values by negative 2. That's all I'm doing. Negative 12 is on the graph. 0, negative 16 is on the graph. And 8 is on the graph. So I multiply the y values by -2 is what I'm doing to get the new coordinates. Okay, so that's all I had in this section. That should be enough for you. The homework is on page 250. You want to look at the problems there for me when you get a chance. And start section 3.3 next. 3.3 is called complex numbers. So far we've worked with only real numbers in algebra. The set of all real numbers, however, does not include all the numbers needed in algebra. For example, there is no real solution to the equation x squared equals -1, because when you square any number, you never get a negative. And so there's no real solution. Okay. Now, I want to be clear in that the way I want to word this is I want to say no real solution, not no solution. Okay, no solution is not correct. Okay, that's misleading and not correct also. So I want to define a number that is a solution of the equation. The symbol I is the basic unit for imaginary numbers and is defined by I squared equals -1 and I equals the square root of -1. Okay, so I want to express each number in terms of I. Okay, the square root of -7, well, that's the square root of -1 times 7, which is the square root of -1 times the square root of 7. The square root of -1 is I, so I root 7. Okay. Square root of -16. It's the same thing. -16 is the same as -1 times 16. And the square root of -1 times 16, I can split that into two radicals. The square root of -1 times the square root of 16. Square root of 16 is 4. Square root of -1 is I, so I got I times 4. You see, the thing with the radicals is that usually when we don't have a radical, usually we write the imaginary part afterwards, just out of habit. Otherwise, if we do have a radical part, like in the first part, we write the imaginary parts first. So I root 7, not root 7 times I. And although root 7 times I would be the same thing, it's just generally we don't write it like that. Negative the square root of -13. Well, the square root of -13, that's the same as I root 13. Okay, because the square root of -16 is the same as I times 4. Square root of -7 is the same as I times root 7. Square root of -13, same as I root 13. There's a negative in front of that, so negative I root 13 would be the answer. Negative the square root of -48. Well, just like -13, I get negative I root 48, but root 48 breaks down. If I use 16 and 3, the square root of 16 is 4. The square root of 3 would be my leftover. Negative 4I root 3 would be my answer. Okay. Now a complex number is a number of the form a plus b times I, where a and b are real numbers and I is the imaginary number. Up to this point, we've learned a specific way with our numbers system, and that everybody in the world learns about our number system. The first thing that we learn about is natural numbers, or whole numbers, same thing. Whole numbers are counting numbers starting at 0. So 0, 1, 2, 3, 4. Okay. Integers are whole numbers and then they're negatives. So 0, 1, 2, 3, and then -1, -2, -3, etc. So what do we have to do? We have to make our current set of numbers bigger in order to throw in all these integer values. And then we learned about this set of rational numbers. Okay, rational numbers are fractions. A fraction is an integer divided by a non-zero integer. Okay, and so that could be a positive or a negative. depending on, what integers we're using. So what do we have to do? We need to make our current set of numbers bigger. Okay, because we got to throw in all these rational numbers. And then we learn about numbers that are irrational. Okay, I don't have those listed, but numbers that are irrational would be like root 2, pi, root 3. Root 4 would not be irrational, that'd be rational, since root 4 is 2, and 2 over 1 is 2. So I don't want to pick just any square root. Certain ones are rational numbers. So now if I take all the rational numbers, ones that are fractions, and then all the irrational numbers, ones that I cannot write in fractional form, and I throw them all together in a big pile, I get the set of real numbers. Okay. Now the set of real numbers does not include all the numbers that I have to know in sampling, because I need to include complex numbers. Complex number is a number of the form a plus b times I. Okay, a and b are any real numbers, and I is the imaginary number. So why we're doing this is so that we can, it all revolves around solving equations. Okay, like if I want to be able to solve this equation, I have to know what a complex number is. If I don't know what a complex number is, then I can only write no real solutions. It's just like if I had 3x equals negative 1. Okay, x is equal to negative 1/3, right? But I gotta know what a rational number is. If I don't know what a rational number is, then I can only say that there are no integer solutions. But no integer solutions doesn't mean no solutions. It just means that the numbers are not integers. Okay, so I need to know something about a rational number in order to know something about the solutions to that set. And that's the same that we do with any sort of equation. We need to know the behavior of the numbers. We need to know if they're, integers or rational numbers or whatever, and because that has an effect over our answer. Okay, I'm gonna have a stop right there, and we'll start up on the operations of complex numbers in the next video.